Hi there, everybody. Welcome to our final exercise walkthrough for exercise 10. Last one, you made it to the end. Just hold on in there for the next little bit. Today we're going to be doing some habitat analysis for the northern gannet nesting sites. And what we're going to be doing with this analysis is selecting sites with a slope greater than or equal to 80%, sites that are near the coast, away from the roadway, and that are at least 1 hectare in size. So you see we have our roads data here, our county lines data, and our elevation data. You should notice as you load your data in that your elevation data is much smaller than these other two data sets, and that's because these two are statewide data sets, whereas elevation data you download in tiles. So you have to select all the tiles that you need for your area of interest. In this case, our area of interest is constrained by the DEMs that we have downloaded. If for a separate analysis you were interested in finding habitat zones all throughout the coast of Maine, you would want to go through and select tiles that cover the entire coastline so that you can run a complete analysis. But for today, we're going to be just using the elevation data that we have provided to us in our data file. Now moving on, we're going to want to make sure our map is displayed to the proper coordinate system. Right now it's currently just a geographic coordinate system, but we want it to be displayed on the coordinate system of the roads layer, which is a projected system for Maine. So you can come here to your layers and find your public roads and select that. And then click OK, and that'll change things up. You'll see things start looking a little bit different. You could have also found the coordinate system in the properties of public roads and then manually select it in the map, but doing it by the layer is faster. Alrighty. Now that we're in the correct UTM zone, we're going to go ahead and start by isolating the coastlines. So the first thing we're going to do is we're going to come here to our county lines, to the attribute table. We're going to find the field that says type, and we're going to see that we have coastline, country or county, and possibly others. What we need to do right now is select the records that have type is equal to coastline. We're going to see that trims our county lines down quite a bit. Click OK. We can see here on the map, it does appear to be that all of the things we've selected are on the coast of Maine. We're going to right click in our table of contents on our layer, come down here to data, and export features. We're going to export the features that we have selected to a new layer. And we are going to call this coast. Well, I'm going to call it coast. You could call it coastlines. You can call it boundaries_coastlines. However you'd like to call it. I'm just going to call it coast to keep things simple. And going to save it. Now we can remove our county lines and see that we just have our coastlines. And this is going to help us for when we narrow our habitat down to areas that are within 100 meters of the coastline. But for right now, we're actually going to switch gears and focus on our slope, since there's nothing really to select here. We don't have anything to determine, we don't have any attributes to select by their distance to the coastline yet. So what we're going to do is we're going to start by selecting the areas that have the correct slope and then move on from there. So I'm going to clear my selection. So we go to this next section about determining the slope. I'm going to close this table. Now we want to calculate our slope in percent rise. We're going to reclassify to isolate the cells that are the correct steepness. And then we're going to convert that raster that we reclassified into polygons. So first thing we're going to do is we're going to come to geoprocessing. We're going to find slope. I'm going to select slope. I'm going to turn off my roads and my coastline to keep my map a little cleaner. We're going to fill out this tool. We want our input raster to be our digital elevation model. We're going to name our new slope raster something helpful. So I'm going to call it 10 DEM. Oh, hold on. Little spoiler for you all. Arc does not like naming files that start with a number. So DEM, 10M slope, and I'm going to put underscore P so that I know in the future, if I look back on this project, that it is in percent rise and not degree. Going to select percent rise for our unit, and we're going to use the planar method, C factor of 1, and going to click run. Give that a minute to run. And we are back with a completed slope layer. It took a little bit to run on my computer, so I went ahead and saved you all the trouble of waiting that I had to do. So now we have our slope, and we want to verify our results. We're going to see in our contents pane that our slope values extend to past 1,000, which makes sense. When you do percent rise, you're going to have very large numbers, versus if you do degrees, you are only going to have it up to 90 degrees. We can also look here in properties, come to our statistics, see our maximum is 338 roughly, which means while we have color classes to 1,000, it doesn't actually look like we have any actual values that get that high. So we can see that's our maximum, our minimum is 0, which just means that the plane is flat. So, and a little trick that I like to do is I like to come here to an area where I can see both really dark cells and really light cells, and I'll just swipe the layer and see if that matches areas where things are changing. Versus like these dark cells that are all grouped together, there's not much elevation changing, so I should see a light color on my slope cell. Versus here, where there's this gray zone on my DEM, where we're going from a higher elevation to a lower elevation, I would expect to see a higher value on my slope, which I do. So I will trust the results that I've gotten. Moving on, we're going to reclassify our slope now. Now, reclassifying is simply taking these values that we have here from 0 to 338 and producing a new output to make things easier for analysis. So in this case, we want a singular output. Either it is 80% or more, or it is not. So we want either yes, it is what we want, or no, it's not, a binary output. You could also say that you could give it 3 classes to reclassify. So if the slope percent is between 0 and 10, it's classified as 1. If it's between 10 and 20, it's classified as 2. And if it's between 20 and 30, it's classified as 3. Anything more is classified we don't care about. So it just depends on what you're doing. In this particular case, again, we just want the old values that are from 0 to 80 to be gone, and then from 80 to our maximum to be there. So what we're going to do is we're going to come here to our Reclassify tool. That is the slope tool. Reclassify tool. Oops. we're going to put in our slope raster. And down here in this table, this is where you are going to reclassify based on the old values. You're going to want to make sure that this field is value and not something else. So this value is the value of the slope, which is what we are basing our analysis on. So we don't want it to be anything like object ID or class ID, which might be in another data set. In this case, the only thing we have to pull from is value, but it's a good thing to double check. Now, there are a few ways that you can edit your reclassification values here. You can either click this eraser button and put things into this table, like this. Or you can click this classify. You can, hold on, I'm going to reload this tool so you can see that tool from the beginning. You click classify. You're going to want to come here to method and tell it to do natural breaks, which is going to let you adjust the number of classes you have. And we want 2 classes. We want a class with the upper value of 80. You're going to want to press the enter key on your keyboard to get these values to save. And then we want an upper class of our maximum, which is already populated here. I'm going to click OK, and we're going to see that it inputs, by using this classify tool, it inputs our table how we want it. Now, our new values that we want, if it's between 0 and 80, that's not steep enough for the northern Gannett. So we're going to want to say no data. We want no data to be in all caps with no spaces, and that's going to tell ARC that to just ignore that cell and leave that cell empty. Remember, you want no data, not 0. 0 is a value. And we're going to make this 1 for ourselves. We're going to name our output raster. I'm going to call this DM slope REC for reclass. But it's up to you how you want to name it. This is just how I name my files. I'm going to click run and let that run until we should end up with a new layer over here. You'll see in our table of contents that there is a single value 1. Now you may notice that you can't really see what we're looking at, and that is because the results we got are very, very small. If you zoom to this layer, you see we still can't see anything, so I'm going to turn everything off till I just have this reclassed slope, and now we can see a little tiny bit of purple, and you can make sure that this is a real bright, obnoxious color for you to find. Purple's working just good for me, so you can see we've got some purple here, saw some purple up here. These are just, we see there's very few spots that are as steep as we want. They all tend to be very thin strips of land, or relatively thin. Now, we are going to add our base map back. I am going to change this real quick to imagery so I can see what's going on. See, it's also a little bit easier to see our new reclassed slope. And the last step in determining the correct steepness, now that we have the correct steepness, is to convert this raster into a polygon shapefile. In going forward with this analysis, we know that we're going to want to trim these areas down even more to match with our criteria for the distance from the coastline and the distance from roads. And really, you have to do that using polygons, points, or lines, any kind of vector data. So what we're going to want to do is get our raster to polygon tool. Make sure it's going the right way, raster to polygon, not polygon to raster. I'm going to put in our reclassified slope raster and name this. I'm going to call this what am I going to call this? I'm going to call this slope classified polygon. You do want to simplify your polygons in this case. We don't want to create multi-part features. We're going to run that. Now to evaluate these results, I'm just going to zoom in until I can see in depth, and I'm going to see that my simplified shapes do match up with my raster pixels really closely. And I can turn that on and off again and see nothing seems to be missing. I'm not seeing any purple flashes come through from where a polygon didn't form. So I'm going to say that's good. I'm going to just turn off that reclassified layer to keep things neat here on my sidebar. So now we're going to move on to our second criteria, which is that we want our nesting areas to be within 100 meters of the coast. So this is where these coastlines that we selected earlier are going to come in play. So we're going to use the select by location on these polygons that we know are the correct steepness. And we're going to select the polygons that are within a distance of the coast, 100 meters. Now, you'll notice I used within a distance geodesic. Remember, geodesic just refers to the method that takes into account the curvature of the Earth. Almost always, as in like 99% of the time, geodesic is going to be the method you want to use. Every once in a while, such as when you're calculating slope sometimes, or if you're in a real crunch for time and you want things to go faster, or you don't have a lot of space for data, you'll calculate things planar, but geodesic is always the safe bet. I'm going to apply this. We're going to see that's going to select some of our polygons, but not all. Losing quite a few here because they're not close enough to the coastline. Click OK. And now we want to save these slopes that these areas that we have now narrowed down by 2 criteria to a new shapefile. So we're going to come here and right click again, come to data, export our features. I'm going to name this steep and coast so I can keep track of what this file's criteria, what criteria this data has met in this particular file. Click OK. And now I can turn this file off and our coast file off. So now we have criteria 1 and 2, our steepness and our distance to the coast met. I'm going to really quickly change my symbology to something a little brighter. I'm going to change the outline color, make the outline a little bit bigger so it's a little easier to see. There we go. Now, we need to trim this down again by our next criteria, which is the distance from the road. We do not want our habitat areas to be closer than 300 meters from the nearest road. They need to be more than 300 meters from the nearest public road. I'm going to turn on this layer. I'm going to see that we've got a lot of roads. We've also got a lot of options on how to do this next part of the analysis. You'll see your instructions list 4 different ways to do this, a couple different select by locations, a couple ways to use the buffer tools and the erase tools. Personally, for me, I like to go with what's going to be easiest and smoothest, and in this case, that's going to be selecting by location our steep coast areas that are within a distance of the road, 300 meters. Only this is all the thing, this has selected all of the habitats that are within 300 meters, so they're too close to the road. I'm going to come here and open my attribute table. I'm going to click switch. So it's going to flip, it's going to invert my spatial relationship. I could have done this here too by checking this box, but I forgot to. And now I've selected all of the areas, all of the potential habitats that are further than 300 meters from the road. I'm going to come back here to our table of contents, export this data again. I'm just going to add on road to this. So now I know that this layer, oops, this is the wrong place to do that. I'm going to want to change the name here. Now I know that this new layer that I'm creating has met 3 criteria: the steepness, the distance to the coastline, and the distance from roads. I can turn this off, and our roads off, and I'm going to clear my selection. And now we move on to our 4th criteria. The nesting sites need to be at least 1 hectare in area. So what we're going to do is add a new field. I'm going to call this area, and then I'm going to do underscore because you don't put spaces in ArcGIS. It doesn't like spaces. And I'm going to put HA for hectare. I'm going to make my data type float so that I can get those long decimal points that keep things accurate. I'm going to save up in this top ribbon. Come back to, I did something silly. I did that on the wrong layer. I'm going to open the attribute table for my steep coast road and make it that field. 1 second. Silly me. Area, hectare, float, save. Okay, now we're back in the game. I'm going to come here, right click on this column. I'm going to calculate geometry. The property I'm calculating is area. Again, I'm going to choose geodesic so we can take into account the Earth's curve. I'm going to use the unit hectare because that's what my analysis calls for. And I'm going to select the correct coordinate system. You can find it yourself by going through this map, or you can just use the drop-down arrow to select a layer that you know has the correct coordinate system, which this does. Yes, that's correct. Click OK. And now we have our areas calculated. There are a few ways that you can select the areas that are over 1 hectare. You can select by attribute. You can also sort descending, so you get the largest numbers first. And then just manually select these 3 records because everything below this is less than 1 hectare. Now we're going to export this data one last time. Now I'm going to call this final habitat. Okay. And now we have our 3 little habitats that meet all 4 criteria for being steep enough, close enough to the coast, far enough from the roads, and large enough. And there we go. Make sure to be saving your project. That was very silly to not save that. You have completed your analysis for this particular project. Typically here is where I let you loose to create your figure as you see fit, but in this particular case, you're being asked to include detailed maps of our final sites, a locator map for context, and an image base map, which is a lot of maps to include in one layout. So I'm going to show you guys real quick how to do that. What you're going to need is for every single map frame, you need a separate map because a map frame can only show one view of a map at a time. So you can't just make a map frame, zoom into one of these locations, lock it in, and then zoom into another one, unfortunately. So instead, what we're going to do is going to create a new map. I'm going to change the base layer to be the same. so that things are consistent. I'm going to come back here to my first map. I'm going to select the layer, the data that I want to display, which is just this final habitat. I'm going to copy it, bring it over here and paste. Now I'll see it's shown up again. And I'm going to do that twice more, so I have 4 of them, so that I can have one map that showcases all 3 sites in this larger area, and 3 maps that show each site more in depth. So I'm going to insert a new map, Control C, oops, C, Control V, with the imagery-based map. It's going to be on this site. And then one last map, Control V, the imagery base map. We're going to showcase this last, most northern site. You also are asked to provide you're asked to provide a locator map for context. So this is helpful to show the relationship between the 3 sites, but it's very unlikely that people will be able to look at this snapshot you're showing them and say, oh, yes, we are in Maine. So you'll also see this in the sample layout that you're given. I'm going to insert one more map. And I'm going to use this map to show where we are in the country. We're in Maine. You can do things like set this coordinate system to the, where did it go? Where'd it go? Oh gosh. To the correct coordinate system that we're using for our other layers. I'm going to find that real quick. ID 83 state plane. Okay. NAD 83. Where'd you go? Oh, state plane. Here we go. Now we're making progress. NAD 83, 2011 US feet, I do believe. I believe that's correct. There we go. And you can adjust the base map if you don't like this particular option to whichever option you do like. I'll go ahead and use this. And now you have all 3 of the map frames that you're going to include on your layout. You're going to come here. You can use portrait, you can use letter, whichever one you think will work best. You're going to come to map frame and just select the map that you want. So I'm going to start with my main area map. This one, let's see. I'm going to zoom to that layer to make things a little easier for myself. I'm going to notice that's kind of hard to see those. So I'm going to come in here and change my outline width. Something like that, so that it's a little bit easier to see what we're looking at. leave my map frame, make another one, and then make the map frames for each specific habitat site. You can mess around with making these equal sizes, getting them all to fit nice. Just make sure that they're in the right spots. Oops. And our last habitat. This is really messy because I'm just trying to show you guys real quick. Something you're also going to want to do is make sure that everything is at the same resolution. So the easiest way to do that is I'm going to find the one that looks the largest. I'm going to see that this has a resolution of about 22,000. And I think 20,000. I think 20,000 will work all right. And I'm going to go to each other map frame down here at the bottom and make this scale 1 to 20,000. And now, because your scale is the same for these three maps, you can use the same scale bar, and it's just more consistent for people looking at your map. Last map frame I'm going to use is this one to showcase where we are in the world. I'm going to just zoom out a little bit here so we can see all of Maine. And make sure you take your service layer credits. You draw them all off to the side so they don't clutter up your map. And you can come here, whoops, in your insert tab to your graphics and text. Get a little polygon, and I know that we're on this section of the coastline, so I'm just going to make a little box. Open up the element tab and make the symbol a little bit easier to see. And there you go. That is how you add multiple map frames to your extent. You'll also notice that you've been asked to include a table with your final area calculations, rounded and with units. Technically, there is this tool called the table frame, and one can include the table frame into your layout. One should never use the table frame in ARC if one loves themselves, because it's one of the most miserable things to try and finagle into looking nice. So I highly recommend doing what your instructions say to do, which is to export this, export this as a high resolution PNG, so like 300 dpi. Put it into PowerPoint or Canva or, I don't know, Paint or something else, and you put your annotations for which site is which, that table and your text through there. You know, you can also put your annotations and your text in here, but I will say it is much easier to edit that kind of stuff not in ARC. So there you go. Make sure you submit your formal map and figure with your final areas, your locator map to show us how these locations are relative to each other, and to your general area, a clear sense of scale. Make sure your symbology is nice and clean and unified. Include your calculated areas for each site and your data credits. Very important, your data credits. And yeah, that's exercise 10. Good luck to everybody. I hope you have a good final few weeks of your semester. And I wish you well. Happy mapping.